Hi everyone. So today we'll be solving the next two questions, that is left rotated array by one place and left rotated array by d places. Okay. So left rotated array by one place. Let's go to this question first. Okay. This question says that given an array containing L elements, rotate this array left once and return it. So we are given an array and you have to just shift the array to left only once. Just by shift the elements of the array to the left side only once. So here we have 7, 8 and 8, 9 is our original array. So you have to shift it to the left by once. Okay, left, we have to shift it the array to left once. Okay, so this 9 will obviously come to 8th place, that is 9 here, and 8 will come take to the 7th place, and that is here. So 7, this is the first element that will always go to the last place, right? This is, you can see, if we take again, some more, it's same thing. This 9 will take 8th place, and then here come 5 and here come 7, and 8 will again, what is 8 is doing? 8 is basically rotating, taking a left rotation, okay, a complete circle, and then it will come here. Okay, so that is what it says. So this 8 will come here. So we are using a temporary variable to store the the value of the first array element of the array, and then we are using a for loop to shift the other elements, rest of the elements of the array to one place before. That is, this I plus 1 will directly shift to I, right? This is the second place, right? So this will come to one place. So 2 I plus 1, if I is 1, then 1 plus 1, that is 2, this is come to one place. This is the logic behind this. Like this, we're traversing it and just shifting the element. This element will come one place before, and then the first element which is already left, we have stored in temporary variable. This temporary variable will directly shift it to the array n-1, that is n-1 is our last element, right? So this thing will basically take the variable and take the value from temporary, which was actually storing the value of the first element of the array, and it will take it and return the complete array. That's it. This is the simple question solution for this. And the time complexity is that O of n, because we are traversing it once. And if they say what is the extra space, then you will say that it is O of 1. Okay, but what if this is the original, what is the given space of the original algo of the, my mother came anyway, what is the original space for the given algo? Then it will be O of n. Okay, because we are taking how many passes we are doing, n times, right? But the extra space is O of 1 because we have used this for loop for the constant number of spaces. So these are the two difference. You have to always be careful what the interviewer asking. You have to always say that if extra space is, then O of 1, but if the given algo, then it is the number of a for loop is running till n times, right? So the given algo is having space complexity, that is a 1 O of n. Okay, so this is the solution. Now let's move to the second question of the day, that is the left rotated array by dl place. Okay, so this question says that given an array with n elements, the task is to rotate the array to the left by k steps. So you have to, same question, you have to rotate the array, like move the elements of the array to the left side, but this time not by once, but with k's number of steps. Okay, so what we can do, let's see. This actually have two solutions. One is the brute force and another is the optimal. Okay, so here I have written something. Let's remove it. Okay, so here n is the n is actually storing the number of elements. It is the size of the array, number of elements present in the array. And then you might say, what is this? See, once you understand this thing, this is very easy. Okay, suppose k is larger than n. N is the number of the, that is the size of the array, right? Suppose n is equals to 5, and k, that is the how many shifts you have to do, that is 10. Okay, we have to do 10 number of shifts, right? You have to do 10 number of shifts. So we have So here what we can see is that, so this is the, suppose the elements, okay, 5 elements we have. We have to do like, k should be like 10 times you have to, shift the array. That is 6 will come here, okay, 1, and then 6 will again come here, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see actually 6 is again coming back to its original position, right? If you notice, let me show it to you more nicely. See, 6 was here, okay. Suppose we take 7, okay. So 7 have to move 10 times, right? So it have to move 10 times, right? So it will come here once, then it will come to 5 plus 2, then 3, 4, then again come to its own plus 5, done. Then again 6, 7, 8, 9, 10, done. This is like, it's coming back to its original position, right? Number of movements is actually 0. So why we have to, why we will just shift it when the original position here is already same? So we just, 10 modulo 5 is 0, right? So it will be, it won't actually bother whether it's moving, because it's already coming back to its own position. Now suppose we take another example and do like 8 is the, k is equals to 8, okay, and we have, suppose a is equals to 7, right? So here you can see that we have to move it 7 times, and number of element is already 7, okay. Number of elements here is already 7. We have total 7 elements. So if 8 is asked to shift 8 times, so it will definitely move 7 times first, right? See, 8 is here, then 1, 2, 3, 4, then 5, then 6, and then it will come here, right? It will come here, but one place is extra. You have to move 8 times, so it will come here. So it's just one passage, you just shift once. Why you have to completely, rotate in? And because that will do a, like, the time complexity and space complexity, everything will be increasing at that time. So to get a smaller value of k, what we will do here is, just 8 modulo of 7, which is equals to 1. So we just shift it once, because that is the answer, right? Why just, completely move it? So that is why we have done k is equal, the new value of k is k modulo of n. And then again similarly, like here we are doing it through the brute force method, like we have done here, this left rotate an array. So here we are again taking a temporary variable to store the, the variables which are left other than the first left, like n minus k times. So we are running it till k, okay, k number of times, and storing the variables which are left. Like suppose here is, okay, so this k is 1. So from till here, this till this much we will be, shift, like storing it, and then we will run it, like arrange it, the previous elements, same like this approach basically. And then again put here we have stored the value in temporary, and then shift it here using a similar for loop here, and then return the array. So this will run till k times, and then store it, and then this will run till n minus k times, right? Left the how many elements are left, and this will again run till k times, like the number of elements remaining in the array, and then return array, okay. So this is one way we can do, that is the brute force. And the time complexity here is, you can say that O of k, and then this is n minus k times, and this part is of k times, right? Because n is there and this will come here, then n can get cancelled and k will be there. So O of k times, and then after we add this, and we get n plus k. That is, you have to say n. You can say O of n plus k, but also tell that big O of n doesn't take any other notation other than the n. It always takes a greater notation. So in this case, k is less than n, so we will get O of n. And the space complexity is O of k right here. Because of the temporary k, we are using an extra space here. Therefore, the space complexity is O of k. But what is the optimal solution? Optimal solution where should be the one like this with the space complexity definitely O of 1. So now let's look to the optimal solution for this question. So if you see here, right, Okay, so the optimal solution here is basically done by a reverse approach. Okay, so after observation, actually, we can see that suppose k here is 2. Okay, number of times you have to shift the array to the left is 2, and the n is equals to 5. So here we have this original. So after k movements, this will be the answer. The k is your 2, right? So this is the final answer, 79068. Okay, this is the final answer here. Okay, and now what we have got that I'll explain you the pros for this one. So you have use three reverse function here, right? So what you can see that here, like we have 68790, right? Now what we have done is that, like, you're shifting it like this. 8 6 first two element, like taking the first two element, that is k is equals to 2. Okay, so taking the first two element, that is reversing it, we will first reverse the kth element. Okay, and then let it be, the rest be as it is. Okay, so, and this will be also the same, 8, and then after that, actually my mother came once again. So yeah, so first, in the first reverse function, what we will do, we will just reverse it till, see, 8 to 6 times. Okay, like, sorry, k 8 times. So k, the first two elements are here, and then we will shift the next elements which are left elements is 790. Okay, now we are reversing it, we get 097. Okay, this is the two thing we have got. Final will be, we will just reverse the whole array in other, like half parts, half two parts, right, from this begin to the tail end. So what we will get a new thing. You can see this is the thing. So this completely will get reversed, 7, then 9, then 0, and then 6, and then 8. Okay, first what we are doing, at first we are reversing it to the kth element, like two elements are there here, so we have reversed this 2, and the left elements again we will reverse it separately, and then the whole array we will reverse it, and then we get the final answer, which is here, we have already gotten earlier. So this is basically the approach behind it. So we have reversed till array first till kth number of times, and then from k to the end of the array, and then again reverse the whole array, that is array from begin to end, and then return the array. So this is the solution, and the time complexity here is that O of k times you have run, and then n minus 1 k times, and then till again n. So the final answer is O of 2n, a little extra space, time complexity than the brute force here, but we have the good space complexity also here. Like we have the good space optimization, that is O of 1, constant number of times, since we didn't use any temporary variables here. So this is the solution for this one. I hope you liked it. There was some disturbance today's video because my mother was coming, and yeah, I hope this thing won't be happening in the next video. Till then, keep learning and keep watching. Bye bye.